Morning folks, in this week's review lesson we're going to go through hash tables, the hash functions and a look at your homework answers. So look at the very basics. What we said this week is a hash table or a hash table was a dynamic data structure that had two parts, the actual table and the hashing algorithm. So we're looking at here, we've got the hash table and the hash algorithm, and in this simple example we're putting in a key is our input. We're putting in the name bond. It's hashed in some type of way that comes up with an address. That address, we can find the record in the hash table. The big benefit of this was we said there was constant time access in it. So a hashing algorithm, it's the mathematical function. It takes an input we call the key. It returns a value which is the location, the hash value or the location. And it says in your screen that when we're using it for memory addressing, the value that's created is a memory location, so we can store records in it. I'm going to focus now, or I'm not going to focus, I'm going to look at a video here that deals with collisions. And then we look at the homework questions.
It generates the same index number for both, but both items can't go in the same place. This is known as a collision. Let's load up the array again, but this time with a different set of data. Mia goes in at position 4. Tim goes in at position 1, just as before. B goes in at position 0. When we do the calculation for Zoe, she goes in at position 5. But then along comes Sue, and when we calculate an index for Sue, we get position 4, but this is already occupied. So we look at the next place along, but this too is occupied. But the next place along isn't, so that is where we're going to place Sue. The calculated position for Len is 1, but this too is occupied. So Len has to go into the next available space. Mo wants position 3, no problem here. Lou wants to go into position 7, again no problem here. But Ray wants position 5, and position 5 is occupied. So is position 6 and 7, so Ray has to go in at position 8. Max wants position 8, but of course this is occupied, so Max goes in at position 9. And finally, Todd wants position 9, but he's going to have to settle for position 10. Resolving a collision by placing an item somewhere other than its calculated address is called open addressing, because every location is open to any item. Open addressing can use a variety of techniques to decide where to place an item.
So that video looked at the concept of linear programming, and the reason I wanted to play that was because it helps with our homework questions. That video is available in your in the classroom, so if you look at that, it's an excellent video and it explains hashing. So a quick look at the homework, and just bear with me as we go through this, and I'll explain how it's marked. The first question, if you can see this, I'll zoom in. It's 1 mark for the calculation, 1 mark for the answer. So if you'd given me evidence of a calculation and evidence of the mark, 2 points. The next question, there was 3 mark points, and well, let's look at how the marks were allocated for this. So explain the operation of a hash table and why the time taken to perform the search is not affected. We're looking at this concept that it's constant time access for insertions and deletions if there is no collisions. So the operation of a hash table, give an overview of a hash table, this idea that it's a dynamic data structure and that there's 2 parts, the hash table and the hashing function. So we've got a mark point for this discussion of it. And then what about the insertions and deletions? They're achieved in constant time O to the n. So we had a mark point that it's 2 parts to the hash table, the function, the actual hash table, and the constant time access for insertions and deletions. Or if you explained that how a key will hash to a unique address given constant time access. Now this question was slightly more tricky. You were given a hash function, an example, and asked to explain its faults. We have got a table. The keys are size is 19. But we've got a bucket size of 19, but we have got, where are we? We've got a key size of 26. So straight away you're going to notice that there's a problem there. That because the bucket size is smaller than the key size, straight away values can hash to the same location. So if I modulus in this here by 19, A will hash to location 19, as will T location hash to location 19. So straight away there's going to be collisions. So if you mentioned this concept that there's more keys in buckets will lead to more collisions, second marking point, the simplicity of this algorithm is going to lead to collisions. If there is collisions, then you're going to explain that involves implementing linear probing or separate chaining, and that's going to remove the efficiency from constant time to O to the end. And finally, I'll just put these answers on screen and explain some of the mistakes that were made. It was the sum of the character value that you were computing, and your the modulus arithmetic was by 13. So for example, study, when we hash it out, went into memory location 6, but computer went into 12. And then you see there is science went into 12, and that's our first instance of linear probing. Where we're in location 12, it's going to have to probe to the start of the array, and it's going to be put into position 0. N went to 8 and there was no collision. Rothmore went to 12 and there's a collision, and it's going to go to location 1, there's a collision, location 0, the collision, so it goes into location 1. And in a real world implementation, you would have to include pointers in these to get to the next location. But for this question, it's fine just to put in the data. Then we had never, where did never hash to? 7, no collisions. A went into 0, but there's a collision, and so on and so on. So there was 9 marks for that, for the calculation and making sure that they got into the correct location. And that, folks, is hash tables and hash functions and an end to data structures. If you have any queries about the structures, post to the classroom or email.